Hello, my name is James Bettis, and this is a presentation that I made for my engineering design class during my H&C.
Introduction. Over the past 4 months, the students of the General Engineering H&C course have been tasked to create their own design for either a toy drone body, foldable gym equipment, or a mechanical cam toy. How did I begin? I began the project by first creating a Gantt chart detailing what I am going to do throughout the 4 months of this project. On top of this, I also completed a critical path analysis as to make sure what tasks I needed to complete first and in what time frame I needed to complete them in. Here is my critical path analysis with the tasks of all the areas of the assignment on the left hand side leading up to the presentation, the weeks in the middle for how many weeks it should take to complete said tasks, and on the right hand side showing what tasks must be completed first and in what order. And now for the structure of my critical path. As you can see here, this is the calculation of the total float time. The LFT going down the second column with the duration of all of these tasks going through the middle, with the EST going down the right hand side, and the total float going down the right hand side. As you can see, all but one, activity J, have 0 total float time, critical path, with the total float times enabled on it. Project design specification. The project design specification is a very important aspect of the entire assignment, as it details every part that must be included in the project along with how each part should function. For example, it should include the ergonomics of the body, the aesthetics of the body, manufacturing process, rules and regulations, and many more. Beginning design work. After completing the planning work on the project and gathering every piece of information needed, I then proceeded to create 3 different designs as to what I would want the drone body to appear as. I based 2 of the designs after drones that had been previously made that I believe are the best that a drone can be, and are 2 of the best in the industry. My inspirations were based off the DJI Maverick Pro, that's seen in the bottom left, and the DJI Phantom 3, that's seen in the bottom right. Here is my first design. As you can see, it's more so based on the DJI Phantom 3. However, I have tried to make it as cool, as child-friendly as possible, as I have implemented the use of propeller guards as to avoid the drone possibly colliding into walls, people, or the kid for that matter, who will be using it. And also I've implemented a landing system which will be coated in a rubber coating as to absorb some of the impact upon landing. And the body will be made from the thermoplastic polyester and will be created using injection molding. Design 2. This one takes more reference from the DJI Mavic Pro, and much like the DJI Phantom in my first design, I have implemented propeller guards for the same reason, as to avoid any potential injuries and to protect the drone itself. This one is not so aimed at children, but I do really like the design of it. The final design, I believe, isn't the most aerodynamically sound drone, but for the demographic I believe it's perfect, as I have based this entire drone around the hovercrafts from the Avengers series of movies, which I believe will be a really big draw for children. The weighted matrix. After completing the 3 sketches, I reviewed the overall designs of the sketches along with every minor detail and inputted these into a weighted matrix. I scored the importance of each criteria on a scale of 0 to 1 to determine what areas were the most important out of the 7 I had previously chosen. These being function, life cycle, safety, recyclability, sustainability, aesthetic, and reliability. The weighted matrix. After organising the criteria and weighting, I began to input the 3 concepts into the matrix, which I scored on a scale of 1 to 10, 10 being that the concept incorporates the requirement flawlessly, with 0 being that the concept has a severe lack of that requirement. On the following page will be a diagram of the weighted matrix with inputted values. Deciding a design. Upon reviewing the sketches and the scores in the matrix, I made the decision to follow through with the design number 1. As the matrix shows, it has a total score of 2.1 above the concept 3, which itself was only 0.4 above concept 2, as shown here. Beginning CAD-CAM. As I completed the aforementioned drone body sketches with several annotations including material type, dimensions, locations for additional parts, e.g. FPV camera, USB charging port, 360-degree view camera, and many more. Along with the weighted matrix, I began to input my sketch into Autodesk Inventor. Upon beginning the CAD-CAM designing, I looked to my previous CAD assignments as to find inspiration on how to perform certain features, such as the sweep tool I used for the drone body's legs, or landing gear. Along with retracing back through all the drawings, I asked my tutor for some aid. However, I made sure to keep it as minimal as possible, as I wanted to solve as many issues that I could single-handedly. I began to design my project rather simplistically, as I started the sketch with a plain square 300mm by 300mm in the X and Y axes, and then extruded it by 70mm to get my base height. After deciding on the dimensions of the base, I drew a 95-degree curve, 80mm leading into the base, and 60mm from both the left and right sides, and cut the area inside of the curve to cut out the object. After the curves of the drone had been cut out, I drew a circle on each of the 4 ends of the base with a circumference of 80mm and proceeded to extrude them by 80mm also. Continuing from this, I began to chamfer the sides of the body by 25mm to get the rounded and curved shape most drones have. Following this, I then drew circles on each end of the drone at 27.1mm and cut it out 30mm deep as to fit the dimensions for the motor that will be placed in there, along with an area to cut into the motor's location which will be used to power the motor. I then drew a square in the middle of the unit 110mm by 110mm and cut it out by 64.75mm deep, as to make room for the devices that will be stored inside, such as the battery, exit wires, and the flight system. I then added holes for the flight system to fit in so it could reach the motors, as well as a gap which has been measured perfectly to enclose the lithium polymer battery that is required. I then flipped the drone to work on where the landing gear would be placed. I measured out the bottom to find where the centre of the drone was, and from there drew lines from the top left of the drone to the bottom right, and one from the top right to the bottom left, ensuring that both lines crossed through the centre. I then went up the lines until I found a distance from the centre which I found fitting for the landing gear placement. Once I had decided, I drew a 5mm hole and cut it out by 5mm. Once I finished work on where the landing gear would go, I added some finishing touches to the design, such as where the first person view camera would go, where the 360-degree view camera would be placed, where the charging port would be located, along with giving the overall design a polish. Finished design. After completing the drone body, I began to work on the smaller pieces involved in the product, such as propellers, propeller guards, motors, landing gear, and the cover for the battery. I did this as to get a better idea of what the finished product would look like, and to allow myself to have even more practice on the Autodesk software, which I do believe I am much better at due to this project. Market research. Whilst researching for the assignment, I found that the drone market is incredibly profitable. Some sources say that the market for drones has already reached a market size of 13 billion, as in the last few years drone sales have skyrocketed, as evidenced by the sales increase from 2016 to 2017, which saw the drone market sales increase by 60%. However, this is partially due to the inclusion of military appliances, as up to 60% is due to the increase in use in drone technology in the military. As in 2016, over 170,000 drones were sold that were priced at $100,000. All in all, the drone market has no signs of slowing down, and it is predicted that by 2024, the drone market will grow to $43 billion, making it a very attractive area for many businesses to capitalize on. Legislation. Throughout my research into the creation of drones, I have come across an extensive amount of standards and regulations regarding the use of drones for recreational use, many being of which would be given to any type of aircraft. However, there are a plethora of rules that every drone manufacturer must ensure that their drone complies to, such as that the drone must only be able to fly at a maximum altitude of 120mm and a distance of 500 meters, and if not, it will be a matter of law However, the way I will attempt to prevent this will be to place a limit on the transmitter of the drone so it does not exceed these limits. Another legislation that all recreational drones must oblige to is that they must not exceed speeds of 25 miles per hour, as if this is exceeded, it could potentially cause damage to the drone, any surface it may come in contact with, or most importantly a pedestrian. For my model, I will prevent this by limiting the speed on the drone so that it can only fly at the max speed of 25 miles per hour. Following from this, drone users are strongly recommended to not fly their drone after dark, as to not cause damage to pedestrians who may not see it, and to not cause damage to anything surrounding the unit. By the laws of the UK, this time at which is considered dark is 30 minutes before official sunrise and 30 minutes after official sunrise. This is known as civil twilight. As it is quite difficult to limit a restriction for the manufacturers to make sure that their drone is not used after midnight or after these times have been set in place, I believe that there will be a possibility to add a timer for the drone so that once the timer elapses, the drone cannot be operated until the timer restarts in the morning. Continuing with the topic of legislation, there are 3 more legislations that must be complied with whilst piloting a recreational drone. The law that the drone must be in a visual line of sight at all times is quite a big one, as users must not solely rely on FPV drones, as they have been known to be somewhat unreliable, as well as the use of visual aids such as telescopes or binoculars. Another area for users to be aware of is flying in the midst of a fog, as this can limit the view the user has for their drone. Another very simple rule is to never fly closely over someone. This can include a gathering of people or just one single person. This is why it is recommended to fly drones away from stadiums and public events where large groups of people may congregate. This will be prevented by the use of sensors all over the drone's body, which will prevent the drone from flying too close to anything or anyone. Finally, the rule that everyone who owns a drone must oblige to by is the rule set by their residential area, and if the area does not have any region-specific legislation, the user must obey by the rules set by the FAA. Quality. The quality of my drone will be as good as it can be, with a high density polyester, which is one of the most durable thermoplastics there is to be used for this project, along with researching what motors to use and many other factors. I also based design around the design brief, which informed us what we must have on the device, as this allows me to ensure that my product will fall under the terms that have been set, which are, as I previously mentioned, that it must have the latest 6-axis flight system, must be able to fly in -10 degrees C to 50 degrees C weather, must have electronic circuitry and a lithium polymer battery, and that the dimensions must not exceed 500 by 500 by 150. Risks. As previously mentioned in the legislation slide, there are a bountiful amount of risks that can happen whilst using a drone and manufacturing a drone, from damaging the drone to possibly severely injuring someone. However, as mentioned before, if the users abide by the rules and regulations set by the FAA and their drone and their local authorities, everything should be okay. Health and safety. During the production of my project, I have made it absolutely sure to keep the drone as safe as possible to make it more appealing to parents who would want to purchase the unit for their child. Due to this, I have ensured that it has a strong battery life due to the inclusion of the lithium polymer battery, and have made it aware that the drone must not be used for more than 20 minutes without either being recharged or having the battery replaced, as to ensure that it will not deplete in charge mid-flight, as it could fall and strike someone below the device. Much of the health and safety of the drone flying lies within the legislations that must be followed whilst piloting. However, I could also aid in the health and safety of the drone by manufacturing the landing gear and also the propeller guards to have rubber tips along every side of them, as to ensure that if it does collide with anyone, any person at all, that they will make contact before the actual propeller blades do. In conclusion, I believe that this drone will appear to be extremely marketable to the public, as I have gone to lengths to try and replicate what other successful companies have done with my own twist on the product. From the battery life to the appearance of the drone, I believe I have done a great job creating a fun and intriguing device for this project, and will hopefully look forward to finding a career in this in the future. Thank you for listening.